Hello everyone, welcome back. This video is going to continue on in section 1.2. This is activity 1.2b that you can find in your class notebook. Really quickly, I just want to review the learning targets for lesson 1.2. First of all, make and interpret dot plots, stem plots, and histograms. We focused more on dot plots and stem plots in the previous video, and this time we're going to take a closer look at histograms. The next two together, we're going to identify the shape of a distribution and describe the overall pattern. Remember, shape, outliers, center, variability, and always including context when you're describing a distribution. And then in the previous video, we compared distributions of quantitative data with dot plots, stem plots, and histograms. So today we're going to focus a little bit more on histograms. The first 2 pages of the activity give you some data that was collected. It says consider the table given below giving the percentage of residents age 65 or older in each of the 50 states. So all the information is there. This is quantitative data, and if you think about the two plots that we talked about in the last video, stem plots and dot plots, they're good for showing individual data, but they're not great for large data sets. And there's 50 different values here that we would have to plot. So using a stem plot or a dot plot might not be the best method. 50 is quite a large data set for those displays. So let's talk about histograms instead. Histograms will group data into intervals and then make a plot similar in look to a bar graph, but we will talk about what the differences is between a bar graph and a histogram. So the first thing that you're going to need to do for a histogram is you're going to want to fill out something called a frequency table. So if you're looking at the screen there, I have each of the percentages divided, 5, 6, 7, 8, 9, and so on. And then gone through and tallied how many states fall in that interval. And then here over on the side is just the actual value. So there are 6 states that had 14 to 14.9% of its population as 65 and older. Again, this is called a frequency table. And this is just going to help you make the histogram. So if you move to the next page, the picture of the histogram is given. And I said it's similar to a bar graph, but I'm going to talk about what's different here. Before I do that, a couple of things that are always important to have in every display. You'll notice there's a title here, percent of population over 65 by state, labels. This is the frequency or the counts of how many states are in there. Now, because this is quantitative data, you're marking things on a number line. When you make a bar graph, you are drawing bars that correspond to categories. So if you're making a bar graph of everyone's favorite color, you might have red, then blue, then green, and so on. And how you space those out really doesn't matter because you're just looking at how many items fall in that category. But because this is quantitative data and you're on a number line, the spacing matters. So when you see gaps in the histogram, those gaps are meaningful. There are no states that have 6% of their population 65 or older, or 7%, or 8%. That gap is meaningful. Another question that sometimes comes up is what to do with values that land exactly on a bar. So let's say the United States now has a 51st state, and we've discovered that 14% of its population is 65 or older. Well, where does that go? 14 is right on the edge of a bin. In that case, we would add this new state to the bin on the right. So when a value lands right on a cutoff between 2 bins, you always add it to the one on the right. Now, how about describing this distribution? So let's go through the important pieces. There's shape. The shape of this is somewhat symmetric. If you said maybe slightly skewed left, I could see that. It's more symmetric though. It does have an outlier right here. The outlier is at 5.8%. And remember what I was saying about how gaps are important. If you didn't pay attention to the spacing and the gaps, you would not be able to identify outliers. So you have a potential outlier here at 5.8%. The center of the graph is somewhere in the middle. We'll say approximately 12%. Oops. And the data has a range of 13%. Now, these are all things that you're thinking in your mind, but when you go to make your write-up, be sure that you're always including context. So you need to be sure that you're talking about the percent of states' population over 65. And you can read the write-up here at the bottom. The distribution of the percent of state populations over 65 is symmetric with an outlier at 5.8%. Center is approximately 12%, and the data has a range of about 13%. That includes all the key components: the shape, the outlier, the center, the variability given by the range, and then it is also written in context. All right, let's take a look at a new histogram. This histogram here is showing just slightly different information. It says the histogram below shows the distribution of the lengths of words used in Shakespeare's plays. Notice that the vertical scale of this histogram is not a count, but is expressed as a percentage of all Shakespeare's words that have that length. So this is another place where the labels are important. If you read this, percent of Shakespeare words. So that means just a little less than 5% of his words only have one letter. Maybe around 17-18% of his words have two letters. This is called a relative frequency histogram. This is not showing the counts of how many words, but rather the percentages. And hopefully all of our percentages, the heights of all the bars, should add up to 100%. So there's a histogram that would show the frequency or count, and there is a relative frequency histogram that shows the percent or proportion of items that fall in a given range. Now I want you to just pause the video for a second, and I want you to write down what you think the description for this histogram should be. Okay, some key parts of your description. We should include the shape. The shape is skewed right. We should include the fact that there really aren't any outliers. All of the data lies within that pattern. The center or typical word length would be maybe about 4 or 5. And the range of the number of letters used is from 1 to 12, so it has a range of 11. And just make sure that your write-up always includes the context of this being the length of words in a Shakespeare play. All right, on the last page, there is a problem that you're going to try. Again, my screen's not scrolling. Apologies. And this talks about using your calculator to graph the histogram. If you haven't already, I do want you to watch that video. We're not really going to do much histogram drawing by hand. It's important for you to have your calculator to do that. So if you haven't watched that video, I do want you to do that. I would also like you to pause the video and try this, check your understanding. Okay, the data that you were working with was on IQ scores, and I'm sure you've all heard of a bell curve before. Lots of people believe that IQ scores fall onto a bell curve like the one shown below. So you should have entered that data into your calculator, and you would have come up with a histogram similar to the one shown. This is with bin widths of 10. And then the question says, describe the shape of the distribution. Now the answer that you see on your page is relative to this idea of a bell curve. A bell curve is anything that is unimodal and symmetric. So you may have used those words to make your description of the shape. Symmetric and with one peak in the graph, sometimes called a normal approximation. Now, the last thing that I would have you do is go to the pages in your textbook 45 to 46 called Using Histograms Wisely. This will make sure that you don't fall into some of the most common errors of making a histogram. If you have any questions, as always, make sure to ask Mr. Bowman or I.